Thank you, everybody, once again for tuning in to Coda Conversations. If you want to catch up on any past episodes, visit us at www.codacombos.com. Today, we have a special treat. We have Kashyap Patel, Google software engineer. Welcome to the show.
Hello, hello.
Hey, thanks for coming on, man.
Nice to be here.
Yeah,
Absolutely.
typically to start things off, we like to get into our guest background. So, can you give us a little bit of overview of what you did prior to your current role and what led up to you working as a software engineer at Google?
So before Google, I was at a company called Medidata. That's also in New York. Basically, we made software for clinicians to conduct clinical trials on. So it might be clinicians or it might be pharma companies and those type of things. Worked there for around 2 years. Before that, I was at a startup called Cortex. I think it has changed its name now. That was in Baltimore. And yeah, there I was for around 4 years or 3.5 years. Plus, I came back for like another 9 months. So I worked there for around 4 years total. There we were basically doing Ruby on Rails applications, and that like we had 3 or 4 different products, and we were a team of total 8 people. In that, there were only 2 full stack engineers, and so we had to basically deal with the entire stack, starting from the database to deployment to the application code, of course, and everything in that terms. So that's where, and that was my first job out of college. So
And
basic,
you said Ruby on Rails?
that's right. Yes, we had 4 applications all in Ruby on Rails,
Okay.
uh, and yeah, that was the front end. Back like when I started, it was just Vanilla JS and jQuery. Um, and so there were not many integrations like React on Rails, and those type of things came later. And
Yeah.
by that time, we had our app like fully built with just jQuery and stuff, so it was hard to migrate. um, but at the end, I got a chance to also make like a Grammarly type of an Chrome extension, not just Chrome extension, but like in general an extension that runs on Chrome, Firefox, and Edge,
Oh,
similar to
wow.
Grammarly.
That's
Basically, like
awesome.
any text box, we show you a widget. If you are a paid subscriber, we show you corrections, and then we make the corrections in line, and that was quite challenging and quite fun.
Nice.
So yeah, that is like my professional journey, and yeah, we went back in reverse order. But yeah, so 4 years around that. In that, like in those 4 years, I was also in San Francisco for around like 8 months, working for another company called Lending Home. They were basically like mortgage or loan providers for people who like flip houses. I don't know if you are aware of that concept. Like
Yeah,
yeah,
flipping houses like
exactly.
you buy a foreclosed
Hmm.
on property and then you fix it up and then you sell it.
Yeah, exactly. So we basically provided mortgage to those people. Uh,
Interesting.
so again, I didn't work on the platform side of things there. I was more on the application or the front end side of things, where we would deal with the onboarding process of any new lead that might be interested in going through the flow and doing the KYC and all of that. So that was fun. That didn't last long though. They had to like cut costs, and I was one of the cost back then. This was
Oh,
in
no.
2019. um,
Yeah.
so this was in 2019, but then yeah, so as I said, I came back to Baltimore again. Like the previous owner or the previous company where I worked for, he immediately responded and said, if you want to come back, you can. So I went there for around 9 more months before coming to New York and started working for Medidata.
Awesome.
Awesome. So yeah, you kind of mentioned layoffs. I'm also in software, and I've been laid off a couple of years ago. I know I got a lot of friends that have also been laid off, but like the market was a lot different in 2019.
Exactly, exactly. Yeah, it was like a lot of open opportunities. The day I was given this news, I went to like those meetups that happen, like SF. I don't know right now, but at that time, a lot of meetups would happen like daily. And I went there, and there were several welcoming people there who were like, "Okay, you can interview with us," and it was quite nice. Or I mean, not nice. It is never nice to get laid off, but like during that time, it
Yeah.
was okay because there are a lot of opportunities. And
So you were in San Francisco at this point or
that's
Baltimore?
right. I was in SF at that point. This was around February 2019.
Okay.
And so yeah, I had to, and again, for me, because I'm not a citizen, my clock starts after I'm being laid off for like 2 months. But they were
Right,
kind
the
enough
clock
to,
starts, yeah.
exactly, yeah, but they were kind enough to like give some buffer period before they notify that the employment has been terminated, kind of thing. So I had
Right.
more than 2 months, so
Okay.
I was able to like go through the interview process and all of that. But yeah, that was in SF, and then so I came back, and rest is history, I guess.
Yeah, like how did you prepare for Google? Like, did you do a lot of studying outside of work, and you had like a tailored plan to be able to pass the Google interview, or did
Yeah,
you?
so actually, like, so Google recruiters reached out to me in early 20, or I think, yeah, it was early 2021 or mid 2021. But at that point, I had just started, or sorry, it was in 2020 that they reached out, like mid 2020. And had just started my job at Medidata, so I didn't want to switch. So I told the recruiter I'll like wait for a few months or a year or something. So I waited for a year, and then I said, okay, let's start the interview process again. And at that moment, I basically started doing a bunch of like graph problems, string problems, tree problems. And it wasn't like a strict routine or anything. Like I would do uh, 2 to 3 or 4 problems a week, kind of thing, not daily, because I had my other job to work as well, or to do as well.
Now,
So
are we talking leak code?
yeah, exactly. Just lead code, and
Leak code.
apart also not not much lead code. Like I did lead code a little bit, but not for graph or tree problems. That I did
Okay.
for more like string and array kind of things. See, like what type of questions are there. But like for graphs and trees, I basically did the free code camp. There's a video on freecodecamp.org. It's a YouTube channel where they like put out videos on how to learn anything from scratch. So they had a graph, uh, intro to graph plus some advanced stuff in graph video, which is around like 2.5 hours. So that I did like thoroughly, properly, like any solution I would write tests for it, and then actually write the code. First go through the video and understand the concepts, BFS, DFS, and then like do the coding myself, and make sure the tests pass and all that. So I did some of that, and then I just read up on some dependency graph algorithms, or like top sorts, and those kind of basic graph things, not like prim and like Kruskal and all that fancy stuff, but just Dijkstra's, knowing how A star works, or what is heuristics, or what type of heuristics to use in A star. And yeah, basic searching, basic traversals. And yeah, I got familiar with that, and then I was able to like take any problem, any word problem. Like they don't ask you directly that, hey, go do BFS or DFS, but like take any word problem, formulate that or model that as a graph, and then use one of these traversal methods or one of these algorithms to basically solve the problem in like a quick way or in an efficient way, basically.
So it sounds pretty technical, the
um,
study that you were doing.
uh, yeah, I mean, sure, it is technical, like learning, but they are basics, I would say, like master your basics.
Yeah.
That helped me quite a bit. And if you master the basics, you are able to like uh, apply those basics in different scenarios. And even if they are like normal word problems, you are able to visualize them in a graph manner and then like solve it quickly. Or even recursion problems are just, I feel that if you like do graphs thoroughly or properly, if you understand them, then trees are kind of the same. They're just like a lighter version of a graph. Or even recursion is kind of same. Even like permutation combination problems are kind of like that. Pathfinding, all of those are just basic graph problems if you can like visualize them in
So
that regard.
similar.
Exactly, similar, yes, yes. But
Yeah.
for
Okay.
that, I would say do the basics properly. Make sure that coding, like visualizing them is one, but then implementing them is different problem. So like if you have enough practice of like just doing BFS DFS and like doing top sort in multiple different ways, you kind of get the gist of what is happening, and then you are able to apply that in different scenarios. And apart from
Awesome,
that,
man.
like I had another advantage, which was like at my previous company at Medidata where I was working, we actually had to make like a string parser. It's not more of a string parser, but like a condition parser. So what would happen is our users or our clinicians would give us conditions in plain text. So they would say like form field A and form field B. If this happens, show a different like a form, or show me a different screen. Or they would say something like if user has said, okay, let's say it's like a diabetes form or something like that, and we have a sugar or glucose level field, and if the user says that my glucose level was more than 100, so they would just say sugar level greater than 100 or something pre lunch or anything like that, then show a different field. So one of the tasks that I had to do was basically convert this string, and at runtime when the form is being showed to the user, we had to actually dynamically either show or not to show a screen. And so like make basically a lightweight AST, like just like any language parses a string. I had to do that on the mobile app, iOS or Android, and basically like parse this tree or tokenize this string that they give me, parse this tree, make it an AST, and then evaluate against this AST what the user gave the value was and what my condition is. So I was doing that. I had to do that in multiple languages and then like explain or like implement that in multiple languages. And so I had some basic AST level traversal as well experience in that role, which kind of helped out in
Now
learning about graph.
you had mentioned free code camp.
Yep.
What was the program that you went through from their catalog?
I can look it up really quickly. It is like around a 2 hour video on graph.
Would you
Uh,
recommend it for people who are trying to get into Google or trying to break into the tech industry in general?
yes, in general, yes. I would say having a good understanding of data structures is helpful. Even though, yeah, there are tools and stuff, but just having a mental model helps you like apply those structures in different contexts, in different word problems. And like having those basics like in your mind does help. So I think free code camp graph theory, if you just search for that, there's a video called graph algorithms for technical interviews full course, and it's like, yeah, 2 hours video. If you do that, uh, like any sort of problem, you'll be able to apply graph theory on that and be able to solve that. I mean, it's not the only thing, of course, but yes, this having this sort of knowledge would certainly help you. At least if they ask you such questions, you won't stumble, and at least you will get the recursion right. How, when to use arguments, when to return something, and those type of things would help you.
So I've been in a few software interview processes. I know one of the important things to do is always talk through your problem as you're solving it. Like, are there any other like pitfalls people often make while
Um,
interviewing?
yes, thinking out loud is definitely good. That helps the interviewer give you tips on, like, if your thinking is wrong, or if like you are going down a different or a wrong path or something. An interviewer can point that out and correct you immediately. But if you're just doing it in your head and just not communicating, then they won't know where to give you a hint or where to like uh, correct you, and it might be too late when before like you start implement after you start implementing. Another
Right.
pitfall,
So
yeah.
talking out the
Exactly.
problem
Even
as
if, yeah,
you're
yeah, even if it's just like nonsense, but
yeah,
it's better to like talk out loud than just to think internally, and that
because it
helps.
gives them an idea of kind of where your head's at, where you're going with the problem, right?
Exactly.
Okay.
So that is one. Another thing is like uh, when or things that I've seen is that they are not able to like I would say not able to come to an efficient solution quickly. So if even if you're not able to come to an efficient solution quickly, try to first give a brute force idea or brute force approach. Try to just give like a brute force idea of what you are thinking or how you would solve this. Tell them that okay, this is like not an efficient solution, this is n squared, or like this is exponential or something like that. And so then if you just at least have that in your mind, then you will be able to see, okay, where am I doing the repeating work? And
Right.
if you do that, then you'll automatically or organically reach like a good solution, that okay, this is the repeat work that I'm doing. What if I sort this? Or what if I, instead of sort, what if I like pre-process the data first, and then maybe use some pre-processing information and then try to solve the problem? So that is something that I've seen. Like, okay, like directly going to an efficient solution is kind of hard, requires a lot of practice, or have good fundamentals in that regards. But like, yes, if you just do a brute force solution, if you just solve the paper on like or with pen and paper, just like in your rough notes or something, and then explain it to the interview that hey, this is what I'm trying to think, or this is what I'm trying to do, they will be help they'll be able to like give you some directions. And then another like common bottleneck is the implementation. Like, even if we have the perfect like solution in your mind, uh, I've seen a lot of people stumble when they're implementing that solution on paper. Like, it's not that I have not done that mistake myself. I have like made a lot of such mistakes as well.
Right.
On implementation side, I do falter. And so like, if you just do those implementation practices outside of this timeline of like 15-20 minutes or whatever you have while solving the problem, and just doing it in your free time, that will make you better. And that actually helps you in like when it's crunch time or when it's the interview time, you don't have to fuss much about like, oh, whether I need to do recursion or iteration or this or that.
Right. So would you say you were doing 2 to 3 leak code problems a day, or
No,
what
no, not
what did
that
that
much.
what did
Yeah.
yeah, what did that look like for you?
So I would say like weekends I would do two or three, and on weekdays I would do two or three kind of thing when on some days when I'm free or something or not playing video games. Uh,
Yeah.
I would, yeah, do around 4 to 6 problems a week, and that I did for around 2 months, 2 3 months, just to get an idea of like what type of problems are out there, like what are different data structures that we can use to like solve up a problem in a quick way. So that was like kind of my strategy, and again, like I didn't go in there with like full set of preparation. It was, I still say that it was kind of a good day for me.
Yeah.
uh, so that also plays a factor quite a bit. And so, but yeah, if you just go there with like no expectation or like clear head and just be like, I'll have fun, I'll see what type of questions they ask, and
Yeah.
like just like have some sort of like relaxed mindset, that would be better. And I would say, like, again, and let me tell you, this was like not my very first try that I got into Google. This was actually my third try
Oh,
to,
wow.
yeah, this was my third try in like last 7 8 years, uh,
Wow.
that I've done to like get here and like
Now they
work.
reached out to you or you
Yes,
reached out
so
to them?
as I said, in 2020 they reached out to me like around June or July or something.
Okay.
And yeah, so this was again like before that I had given the interview in 2019, I think. 2019 I had gone through like two screening rounds. I think after the second screening phone screening round, after the second phone screen round, I was like rejected, and like they said, we won't move forward with you. And so like
Now,
I kind of give up.
do they explain why you were rejected at that
No,
time?
they don't give out those reasons.
Oh, they
They just say,
don't. So
yeah.
you have no idea where you went
Exactly.
wrong.
I mean,
Yeah.
I think you kind of get a
That's
sense.
tough.
Yeah, it is tough when you don't get any like reason, or and you don't know where to like improve. But after the interview, also you can kind of get a sense of, okay, I was able to solve this problem, or I was not able to solve this problem. If you are not able to solve a particular problem, uh, that's not the end of the road, but you can still like, I've had friends like who basically did not actually solve the problem, but they were able to like talk through the problem,
Yeah.
and then like they were able to incorporate the hints that the interviewer gave them. And at that time, like uh, if you are able to listen and like apply those hints that the interview gives you, that is also a positive sign. That is also like a good sign where you are able to like incorporate feedback. So that also works. So it's not that, oh, you have to solve this one problem in like a quick go. If you work with them and reach a good solution, that's a positive sign. But yeah, the second round that I did the phone screen, I don't remember what they asked or like uh what happened, but like, yeah, it wasn't like a smooth sailing process. Like I think I
Right.
coded something wrong, and then the interview had to point out that, hey, what happens when you apply this input, and those type of things.
I see.
So yeah, we often hear about the interview process, but like once you get past the interview process and you get the job, what should somebody do to prepare to actually work at Google, or is it just like a typical tech company?
I would say it's more or less a typical tech company, but what is different is, so I work predominantly on the front end side of things, mostly on the front end code base. So what the stack that we have at Google is quite different. It's not React or Angular. Some apps do use Angular, but our team or our app does not use Angular. We have an internal framework called Viz, which is quite a bit different. And so I would say that there is a bit of a learning curve in the beginning, getting used to the tools that they have, getting used to this framework that they have. Uh, try like the version control is bit different, and that there is a bit of learning curve there, but after that it's quite smooth sailing. So for that, I would recommend that new learners do not just learn a particular framework. They learn like fundamentals of the language. They
Right.
learn how JavaScript works, what is an event loop, how promises work, how can you parallelize tasks in JavaScript, what are some of the common uh, issues that can happen in an app. And if you have that good fundamentals of the language, then you are able to like switch, or you are able to like apply that knowledge to any framework. And then once you get to know the framework, then it's like easy sailing. Then it's more like how do you like solve a particular problem in different ways. Like there are so many different ways you can solve the same problem, but like uh, how do you actually use the right frameworks or right abstractions that are there, and get to a nice solution that is like in future extendable, and ensure that you're not adding tech debt. I'm not saying that's always the thing that we do. Sometimes when there are like crunch timelines, we have to add some tech debt and like rush through a feature or something. But this is a general practice that I would say one follow.
Sure. So for the audience that might not be aware, what exactly is tech debt?
So tech debt is something that you apply a band-aid to fix a particular problem, but uh, you are basically adding more stress or more strain for a newcomer to come and like go through the code base and understand what is going on, just to make fix a quick bug, or like just to add a feature that is like some people are asking that we ship within a certain timeline. We are not able to follow the best practices that are set by the team, or like, yeah. So in that case, we basically just make sure that the thing works, rather than making sure the thing works in the right way, and using
Right.
like all the best practices,
Okay.
and not like add time complexity, or just like add race conditions or stuff like that. If you just keep applying band-aid, uh, code base can get ugly, and then it's pretty hard for a newcomer to come and like, not just for newcomer, it's hard for newcomers to like just first understand the code, but it's also hard for like peer engineers to reason through the code. And it's also hard for yourself. Like if you look at the same code after 2 3 months, you won't remember much of it, and you won't know why this is done. So we like have a good practice of like adding like a to do, and opening a bug for this. Hey, clean this up when you have some time. And we do that quite a bit, but it's not perfect. But yes, tech debt is basically a short term win for a long term loss, in terms of like the
Yeah.
code quality and just general code health.
Interesting.
So does well, obviously it's going to be team dependent, but does Google in general place like a high importance on testing, especially unit testing?
Certainly, certainly. So any code that you write, or any PR that you try to add to the code base, will not be approved unless you have some code, unless you have some tests. Sorry. So like what happens is, let's say you are adding some uh, let's talk in terms of React, where let's say you add a component. You need to make sure that you add some tests for that component that covers the entire use case of that component. It checks for like edge cases. It We also do some sort of like integration test, where we test out the entire flow. So let's say you click a button, it opens a dialog, and then you can interact with the dialog, and then you exit the dialog after taking some action. So we have some tests that test that entire flow as well. Those are more like integration tests. We don't have like Cypress or anything like that. We have our own system where we can set up this entire structure, and then take pictures, and like interact with the dialogue and then close the dialogue and make sure the right calls were made, right like metrics were recorded, and right yeah, API calls were made. So those type of things, we mock most of these things out, uh, just like any like React library does. So yeah, that is kind of similar, but yes, any code that we submit will have to have tests. So this is about a new code, but let's say you are fixing a bug. uh, you fix the bug that works on your local, but then you also need to add a test that makes sure that fails without your fix, and after you fix it, make sure that passes, and that test also needs to be part of that same PR, and so that we can say, okay, we have like actually fixed the bug and we have added a test to do the same.
So the documentation on all of this is pretty extensive with Google.
Yes, but it's always lacking.
Yeah.
It is, there is a lot of documentations like about all the different practices that you go through, what are the good practice that we follow for that particular code base. So all the different code
Sure.
base have that stuff, but there's always room for improvements.
Sure.
Yeah, I've heard like one of the key ways to, as you move up to really make progress is be good at documenting, be good at writing clear, concise documents. Because as you move up to like more architectural type roles, you're pretty much focused on communicating, creating charts, graphs, things of that nature.
Exactly, exactly. That certainly helps. The more images, the more charts there are, the better it is. Uh, Documentation, that is one of the big part of like the ladder, that if you want to go up or higher up, it's not much about the coding complexity or the work or the code output that you give, but it's about the overall, like looking at the big picture, making sure uh, that you actually set a framework out there, so that like any other person can just read that documentation and implement that. You don't have to like be there to code it yourself or anything like that. You make sure that you like cover all the different surfaces where the app might run, all the different constraints of those different surfaces that a code will run, and make sure that it is like proper, and you have covered, or you have like thought of different use cases. And
Yeah.
also we have this good process, like if you have a good idea or something, you can write a one pager or a doc, and then ask for the peers or the team seniors to like go through the doc, and they are quite helpful in like giving you comments or showing you your blind spots. It's not that you go through code and you'll know everything. Some of the things you might not know, and so they will basically give those feedback, and then you can incorporate those feedback into your document or into your design, and then start coding.
I
And
see. Yeah, it does sound pretty comprehensive though.
mm-hmm. Yeah, it is. We have like tightened the ship on this, because earlier during COVID we had to like ship out a lot of features, or that's what I've heard. I was not at the team during COVID, but like we had to ship out a lot of features quite fast, and then it added a lot of tech debt, and then every team was doing the a similar kind of thing in different manners. So like now we have certain contracts that you should follow or you should go through, and make so there is like more consistency in the code, and so one member of the team can like go to the other part of the team or another like part of the code base, and is able to understand and like able to reason through the code and make changes to that code as well.
So something I'm finding that's really important outside of just being a great coder is just learning leadership skills, like learning to take initiative. Like if you want to progress, you have to do things without being asked.
That's right, yeah, like that is definitely one big part here. uh, just not be afraid of if you have a good idea, make sure that you like make it visible to a lot of people. Don't just keep it in your head.
Yeah.
Like, I am not perfect in this regards. I sometimes just do that. But yes, so another important thing is, like, if you want to go up, it's good not to just have good coding skills, but to also have good writing skills. Like, you should be able to explain your ideas in a nice manner, such that anybody who reads it without any context can understand it.
So the
And
documentation is
exactly
incredibly
is really
important.
important. Yeah.
Yeah.
Even if you look at the AI tools, they don't do all the job for you, like, just out of
Yeah.
the box. You have to go provide good prompts, or good, like, structure to your prompts, such that it can, like, do whatever.
I
And
guess one question I would have for you is how has AI affected your job, moving forward?
um moving forward, I would say, like, for us it's not that big of an issue, because, like, our code base is super mature and, like, super big for, like, AI to just understand and give you some hints. But
Okay.
one thing is there, which is like, we have some sort of rudimentary code completion. And so, like, it does reduce some of the like, boilerplate that you have to write, for, let's say, writing test. Like, have to, like, you have to set up some code, and you have to write a lot of repetition in stuff. So that is something that AI is good at. Like, if you add a comment or something at the top of what you are trying to do, it is, like, rather good at suggesting some suggestions. But it's not perfect. Sometimes it makes a lot of, like, boo boos mistakes. And so you
Yeah,
have
right.
to go through that and make sure that this is exactly, or this is what you want. So that is good. Like, some code completions, like variable completions, and all those things are quite good. But in terms of, like, actual problem solving, like, it's not that your code is just resides in one file or a couple of files. It spans through multiple different files. It spans through multiple different uh, dependencies. Or it we have a lot of dependency. We use some like, dependency injection to, like, get some of the data models and stuff. So it does not have that context of what you are trying to get, or what you are trying to, like, do. And so that is something that AI right now is not good at. Or it's, I don't know if it will ever be good at that. But, like, basically, yeah, refactoring the
Right.
entire code base, having that knowledge, certainly is, like, a bigger learning thing than, like, just doing prompt, or, like, something like that. We have some, or at least I use AI sometimes to, like, so we also have kind of an internal chatbot for codebase, particularly, not like Gemini or the things that is outside. uh,
Okay. So
that
for internal use only.
exactly for internal use only. So where we are allowed to, like, uh, upload our source code on it, or our source code, and then basically ask questions. So let's say, like, you have a 2 3 thousand line files. uh, Instead of, like, going through that file yourself, and trying to isolate what parts are important here, you can ask that to the chatbot. Or it won't, I don't know if it will take 2 3 thousand line files, but let's say, like, 2 3 400 lines file. You can ask it to, like, isolate certain parts of the feature that you are working on, and see what it is doing, and get, like, a general overview of what it is doing. And, like, then you can formalize that in doc, and then having that concise word explanation of the code will, like, give you better understanding of, okay, this is the area where I can try to make a change, or make some optimization, or make some improvements. And that basically, then you just say, okay, let's try to do that in the code. And so it's good for some people struggle with writing English or documentation, I would say. Some people struggle with writing code. So it's like mix. So if you, I would say, use that tool to improve the part that you are not good at.
Right.
So I try to do that sometimes. But apart from that, like, yes, because like the internal code base is quite complicated, and like it like goes through multiple layers. Like it's not always just front end or the back end. Like there are
It's
certain,
not just components in React, for
exactly, it's not
instance.
just
Yeah.
components in React that you can say, hey, make me an autocomplete or something like that.
Yeah, right.
So that is something that will still require human intelligence and human input. And so like just having those contexts, knowing the surface, knowing the product that you're working on, does give you an advantage in that regards. And AI is not able to like grasp that entire context in giving you the answers. It
Right.
is sometimes quite dumb, like the internal tool that we have, and so it's not highly reliable. um,
Yeah, I think that's a lot of people they're in fear of AI. They think it's just going to replace every job. But if you can think on a higher level, if you can understand how systems interconnect, if you can actually understand the code, then you should have job security because somebody still has to outlook the output of AI and understand what it's doing, making sure it's doing the right thing, if it's safe and secure.
Certainly, yeah, that is definitely true.
So yeah, I think it's all about the big picture thinking going forward, and not just being like a quote unquote code monkey.
Exactly, yeah. Yep.
Right.
That big picture is something that only like you have to go through systems, like you have to read a lot of you have to like just I mean, read a lot of blogs on how those systems are built. They're not just conventional solutions that you can apply to any problem. You have to come up with some innovative solution that is just specific to your use case, and that is something that you have to like figure out, and by talking to people, or uh, yeah, talking to people who have more understanding of different surfaces that you're dealing with.
Okay, so what would you say is, for our listeners, what is the most exciting part about working for a company as big as Google?
I would certainly say the people, and like just uh, talking to a lot of different people gives you a lot of different perspectives. Anytime like I come up, or like I have issues or a problem, like I go and talk to certain people, and they'll all come up with different solutions, which is quite unique to have. Uh,
Right.
and that basically builds your perspective on like what you can do to uh, like think of the same problem in different ways. uh, that is one big part, like just having that raw like expertise and just learning opportunities is something that's really exciting. That also comes with a bit of a challenge, wherein we have a lot of different like opinions, and so like what to do when like, there are a lot of good solutions. What solution, or do you should you
Which
go?
one wins out
Exactly,
ultimately? And
exactly.
which one gets picked at the end of the day?
Yeah, that is kind of a challenging part. But yes, having different perspective definitely helps, and like it basically like removes your blindfolds as well. Like you might be just thinking of this problem in just one way, and then when you talk to people, like they come up with a lot of different ways, and you might not even have thought of. So that's how like you grow your learnings and your software skills.
Well, yeah, Google has a lot of incredibly smart people, and obviously, there's more than one solution to a problem. So, when there's multiple suitable solutions, how do y'all decide what typically wins out?
So like that is an open question, I would say. So what we have are certain like not frameworks, but certain like schemas of things we should adhere to, that all the teams follow. And so even if we have different solutions, we try to like make sure that it's more of a approach that is like adherent to a particular schema, or to to like a certain way of doing things. Another one is like to basically list out the pros and cons uh, of doing it with one way or doing it with the another way. And like think in terms of like code complexity, think in terms of like the amount of code that you'll have to write for this, like how much time it will take is another issue or another dimension that you can think on. And also something like um, yeah, one challenge that we have is we need to make sure that the code runs on multiple different surfaces. And when I say surfaces, like multiple different platforms, may it be web, may it be like a hardware, may it be like a Chrome OS device, or AOSP device or something like that. How do we make sure, or
Right.
how do we like make sure that the solution works for all these different surface in a nicely
Now,
abstracted manner.
are we talking DevOps here?
um
Stuff like Docker?
no, so we do not have those type of containerized solutions for deploying our applications. We have like a whole different infrastructure for that. But this is more about, if you make a particular feature, for example, a browser, how do you make sure that the same feature works with like the same code base on, let's say, a non-browsery solution like an AOSP based device, which is running the same underlying code, which is like AOSP device or a Chrome OS device, or like think of uh, like imagine that your app is being used on some other app. So imagine like an
Yeah.
Excel, like a Google Sheets feature being used on a Google Docs application. How do you make sure that that integration is easy for the Docs team to make, or for the Sheets team to make? And so you need to make sure that those surfaces are taken into account. Uh, think of like a video conferencing app like Google Meet, and we need to make sure that Google Meet call can start from like uh, Google Sheets, or from Google Chat, like the internal version of Slack, internal version for messaging that we have similar to Slack. So how does all these integrations work? So those type of things are taken into consideration while taking a particular approach. And also time, as I said, it's also a huge factor. Like we can come up with all the interesting and intelligent solutions, but then if it becomes very hard to implement, that's not like a feasible solution. So all of this are taken into considerations. What are the performance implications? Will it cause any race conditions? What are like the metrics, or like uh, as in like, yeah, performance not just for the application, but like performance in terms of yeah, I would say just not just the front end application, not that the uh, not just look at how it makes your application slow, but also just look at like the backend integration, or like the API calls that you are making are also quite performant, or like what type of information do you need to send, what type of information do you get back. All of that is taken into account while building this type of things.
Now, on a higher level view of all this, would you say that that's where the time constraints are coming in?
uh Time constraints, as in like for code completion time wise.
Sure, for features, yeah.
Yeah, exactly. Yeah. So going through that design review does take some time. but as I said, like the team is quite active on that regards. Like if you it's a small change, it's usually resolved in a less than a week of time. But if it's like a large infrastructural change wherein we change some protocol of how the communication is being made, or like how the data is being sent, or those type of things, that does go through some churn, and that takes some of the time. After that, coding wise, it depends on the complexity of the feature, but that is bit low. But also another thing that takes up the time is like integration, and making sure that if you are, let's say, working with some other team, that also takes up some time, as in they would have some different infrastructure, you would have some different infrastructure. Now you need to maybe converge them, or make some common pieces, extract out some common pieces, and like make them common so that both the apps can use it, or all the different apps can use it, those type of things. So those type of exploration work also takes a lot of time. It's not just the code, but like yeah, those type of exploration features where you are just going through the code base of some other app and trying to see if that solution maybe can be used in your situation, in your use case, or something like that. So all of that takes up the time. You write out what has, like, what observations you made, what parts can you pluck out, or what parts can be reused, and all of that. And then the design review team comes in, and then we basically make sure that if, like, the design is approved, and then we start coding. So yeah, coding
Right.
is not the always like the largest time sink. Sometimes it is,
Yeah.
but many of the times it's this type of things where we need to get a consensus, and we need to make sure that we reuse a lot of things that is already built. One thing about Google is it's like a very large code base with, as you said, a lot of smart people. And so a lot of different problems that you might have encountered might have already been solved by some other team. And so writing that doc, and writing that or making sure that your idea is visible, also gives other people a chance to like point you in that direction. Hey, this is something similar to what I've seen in some other app. Let's try to see if they have some solutions that are already working, and we can leverage that, or something like that.
Now, what's a way to level up? What's a way to move through the ranks at
So
at
that's
Google?
yeah, so that's a hard problem. I've not been able to do that quite a bit, but
Yeah.
the advice
Yeah.
that I get is basically make sure that you are not afraid to take on like a large chunk of work. Large chunk of work, as in like not just small feature work, but something that scopes out multiple quarters or multiple months,
Yeah.
and make sure you are able to communicate and interface with a different team, and make sure that they are in the loop of what you are trying to do, and just basically try to get those consensus, and try to like make a change such that a lot of different surfaces, a lot of different teams are able to leverage that change, and are able to use it.
I
That is
see.
one thing. Another thing is the monetary aspect, which is like, let's say you're working on a feature that might be like very critical, and which is like pushed on by the executive team or something like that, uh, and that yields a lot of money, or that yields a lot of increase in the usage of a particular app. That can also be a part of, or that can also give you like a chance of getting a promo or something like that. But again, uh, like, it's basically, yes, taking like a long term project, which is also ambivalent. You don't know, you don't always know the right solution when you actually start that particular project. It might take different turns, it might have
Right.
like a lot of ambiguity, and in that regards you should be able to cope with that, and you should be able to come to a resolution. It's very easy to get like stuck in when like you have all these different approaches. You like, okay, I just want to do this code, why can't I just do it in this manner that actually works and all that. It's
Yeah.
not always about that, and it's more about like looking at that big picture and making sure that you are building it the right way, and you are able to like leverage all this infrastructure work that is there, and
So, okay,
use
so
it.
let me ask this. Are you expected to do a lot of work outside of your normal work schedule? Are you expected to, study up on leak code and graphs and, all types of stuff like that outside
No,
of work?
that is definitely not the part or not the culture, work culture at Google. It is more like uh, just learning about data structure algorithms can be useful if you are working on some very efficient or like very low level stuff, but more it is about like learning the systems,
Yeah.
learning the internal tools, and how can we leverage those tools to get better outcomes and like to get better results. And that just does not come with like just like coding and like just learning the graphs and algorithms and all. It's just more about making sure that you are able to um, like leverage the tools that are already
So it
there.
goes deeper is
It
what you're
goes
saying.
definitely
There's
goes deeper, yes.
there's depth here.
And it's definitely more about dealing with ambiguity.
Okay.
With this large term projects, you are never going to get the perfect solution, you are never going to get like the always the right answer. So it's about how do you deal with all this and make the right compromises while navigating this large path.
Now, do you work on stuff like Gemini or any of the AI features at
Uh,
Google?
no, I do not work on any of the AI features. That I think is a different division. I work more on the application sides or application side. So I work basically on Google Meet and Google Meet in rooms in particular, basically the conference rooms that we have or the conference room hosting Google. So that is my team, or that's the team that I work on. So we may have, or I mean, yeah, I think in terms of Gemini features, like Google Meet is integrating more Gemini or AI features into the application. So I might get to review some CLs or something like that, but that's a whole different team,
I
and
see.
that's like a whole different org that
Right.
drives that and that pushes those features.
Yeah, that
Awesome.
makes sense.
Yeah, man. We're at the top of the hour, so we have to start closing things out. But did you want to leave our audience with any closing thoughts?
Closing thoughts, I would say, uh, don't get discouraged by all the AI tools that are coming out and thinking, oh, my software job is like over or like I won't have any chance. It's just more about learning the basics. Software will give you like a way to think about problems and not just like your work problems. It can also be your life problems, and just it basically teaches you how to think. So just learning to code is a good skill to have, but also like leadership skills and just communication uh, is also a very important part in software engineering, and that is something that you should also learn and just try and do more of that in general. Apart from that, yeah, just keep coding. It's a fun thing to do. Uh, Try to like have fun as well. Just don't be in front of your computer screen all the time.
Yeah.
uh, but yeah, have fun. Like, yeah, life is all about balance, and so yeah, just do the fundamentals, learn the basics, and then like a lot of different opportunities open up. And yeah, just don't fall into the trap of a framework or be of like a framework fanboy. Be versatile enough to like
Yeah,
learn different frameworks and see different frameworks. You don't have to like make a same to do app in all those frameworks, but at least see how different frameworks handle different things, like migrate database migrations or database schema or ORM, or like how different
absolutely.
front end frameworks differ in different ways. And yeah, try to be versatile and not be just one framework person.
Yeah, one final question I would want to put to you
Hey,
is,
Brian, we
okay,
gotta close the show down,
if
man.
if you could go back in time, what was the main tip that you would give yourself?
Oh, um back in time. Okay, that's a tough one. I would say be kind, be nice, uh and like respect people. uh that is something that I would say to my past self. um yeah, it's easy to like just be in this software, you are just coding and like it kind of dehumanizes you. At least I've seen that with myself a little bit. And so you don't realize that you are being kind of rude to other people. You might inside also not think that hey, you are being rude or you are being like impolite to other person, but you might be, and they might not, they might not tell you, or like they might just cough it off. uh, but like yeah, just be kind and polite in your like answers or in your like references. Everybody's stressed out, so
Yeah,
uh, just be
that's great
mindful of that.
advice. Yeah, that's great advice.
Well, yeah, man, we definitely appreciate you for coming on the show. Just to close it out, where can everybody find you at if they want to reach out to you?
You can find me on LinkedIn. I think it's KH Patel 4991 is like the slug in LinkedIn. And yeah, and I don't think, yeah, I don't use Instagram much, or I have a profile but it's logged and I don't use it anymore. Or Facebook, you can find me under the same slug. But yeah, uh,
Awesome, man. We definitely appreciate you for coming on. Anytime you back, we can have you back.
certainly, certainly,
Yeah, I think there's a lot more we can get into, and then discussion about AI and etc.
certainly, yeah.
Awesome,
Absolutely.
man.
And we like to thank everybody for tuning in. We'll catch y'all next time. Peace.